Control valves are one of the major equipments in the instrumentation industry or in the process industry, and there are lots of people who are engaged in reading the control valve datasheet or preparing the datasheet or reviewing the datasheet. And there are lots of confusion about the different what should be the different parts in a datasheet and how we should fill it. So in this particular lecture, we'll be discussing about the different parts of the datasheet and how it is normally filled, what are the datas you can expect, and what is the typical format of a control valve datasheet. So let's begin. So this is just a snippet of a control valve datasheet. Maybe you are not able to view it properly, but in the subsequent slide, it is zoomed in and you can have a thorough view of it. But the intention is here to show that the, there are like 8 different components normally in an instrument datasheet or control valve datasheet. So it first starts with general, then it provides the details about the pipeline, then about the process condition, then calculations, body and trim, actuator, make and models, and then notes if applicable. So now let's look into it into more detail. So this is the zoomed in view of the datasheet as you can see. And the first portion here is the general. So within general, it contains the job number and the customer. Job number can be the PO number, right? Our customer can be XYZ. The project name can be some upgradation work, right? Now then there will be tag number. So tag number can be something 123 XB 1234, something like that. Then what is the service? Whether it is an water service or any oil service, what is the service that you can write? Then what is the line number? And what is the PNID number? So PNID number, it depends on the project and the organization, but PNID number something like it will be 123 1245, something like that. And the line number can be line size, what is the material, whether there is some insulation or not, all these details will be available. Then comes the hazardous area classification. So here you can see it is written as zone 1, and then it is group 2A and group 2B, which is gas grouping, and then the temperature classification. If you are not aware what is hazardous area classification is, please look into my other videos in the description. Then the ambient temperature, what is the ambient minimum and maximum temperature? On this case, minimum is 1 degree centigrade and maximum is 46.1 degree centigrade. Then what is the allowable dBA? dBA means the decibel, right? So this is basically what is the allowable noise level. So here it is given as less than 85 dBA. Then this valve, particular valve is the pneumatic valve, and for this it requires air supply to operate. And what is the minimum and maximum air supply that is available? So that is 4.5 kg per centimeter square is the minimum pressure and 7 kg is the maximum pressure. Then certification or approval type. Is there any additional certification or approval that is required for this valve? Then that can be written here. Then follows the pipeline. So the valve is installed in a pipeline, right? So the pipeline details is required. So Normally the inlet outlet line size and schedule, as you can see here, it is 16 inch 150 pound in the inlet, and outlet also it is 16 inch 150 pound. Then what is the pipe material class? It is 150 pound and pipe material is A19A, and there is no pipe insulation here. Then what is the fluid name? You can write fluid name as maybe amine solution or water, right? And what is the fluid state? Fluid state, it can be liquid, it can be gas, right? Or it can be biphase. Then what are the process condition? Right? So process condition is whether it is corrosive or erosive. If I am taking like it is an amine solution, then it is erosive, it is toxic also, corrosive, erosive, and but it is not toxic, right? Then what is the maximum shut-off dB? What is the critical pressure and what is the critical temperature? So maximum shut-off dB is 10.7 kg per centimeter square. Critical pressure is 207.6 kg per centimeter square, and critical temperature is not mentioned because maybe in this case it is not required. So then what is the design pressure and what is the design temperature? So design pressure is 10.7 and design temperature is 80. So this will be our design. So based on this pressure and temperature, the valve will be designed. Next, there are three situations that is provided in the case of the control valve. What is the minimum flow situation, what is the normal flow situation, and what is the max flow situation? And in these three scenarios, what will be the flow rate, what will be the inlet pressure, what will be the pressure drop, what is the inlet temperature, what is the inlet density, compressibility factor, viscosity, specific heat ratio, vapor pressure, and molecular mass, right? So all this data should be there. Now, until this portion, actually this all this data is normally filled by the process, and until all this data is normally available in the process data sheet, and based on this process data sheet, instrument team prepares the instrument data sheet. Some initial information like in the general information, it can be filled by project or made available to the uh, process team for preparing the process data sheet. But all this data, as you can see, they are process related, and the process team provides this data to the instrumentation team. Now, the next part, which contains the calculation, the body and trim, and the actuator, this is done by the instrumentation. So here the flow coefficient CV, so it can be like something, suppose 150. Then what is the trouble you anticipate here? Now this datasheet also can have multiple stages. So for example, it can be very initial stage, so where uh, the process datasheet is received by the instrumentation team, and they prepare the initial datasheet and then hand it over to EPC for further review and calculation. EPC then sends it to vendor, and vendor checks it and does all the calculation and hands it back to the EPC, right? So this is very initial stage where there is no CV, no trouble, no DB has been mentioned. So this, after calculation, this data will be filled here. Now body and trim, right? So body and trim, these materials are normally given by the EPC or the client based on the service temperature and pressure, and design temperature and pressure. As you can see, it is written like what body type and material. So body type, it is they are selecting a globe valve here, so that's why globe. And what will be the material? It is ASTM 216 group WCB, right? Now what will be the body size? and what will be the trim size. So these are kept blank or star. This can be filled by the vendor. Then rating is 300 pound, and the rated CB is not mentioned. It will come from the calculation, and the expected characteristics is linear. Then end connection and rating. This is raised flange and 150 pound, plug blank, plug balance, balanced or unbalanced. So it is also not written. It is left for the vendor to decide whether the balanced or unbalanced plug is required. Then bonnet type. Bonnet type is what is the bonnet type and what is the material that has been mentioned. What is the flow direction? What is the FL or XT? Whether there is a guiding required, number of ports, what will be the trim type, then what is the plug, ball and disc material. This is basically weighted part. So weighted part, it is mentioned at SS316. What is the sheet material? Sheet material also mentioned at SS316. Cage and stem material is mentioned as 316. Cage requirement has not been exclusively provided by EPC. It is upon the vendor to decide whether there is a cage requirement or not. Gasket material has been specified, but normally this material when goes to vendor, they review it and they provide their own recommendation, and then it is up to vendor and EPC and client to decide whether that material is suitable for their purpose or not. Then there will be some details provided for the actuator. What is the type, size, maximum allowable pressure, rated travel, whether the actuator, what will be the actuator fail position, whether it is fail close or fail open, whether there is an hand wheel requirement, here it is given as no. Then goes into the positioner, right? So positioner, what will be the signal inlet and what will be the outlet, whatever maybe. So both it is normally same. So it is digital FF, it is written here. In other case it can be 4 to 20 milliamps, right? And the type can be hard also. Whether there is a bypass for this positioner, so it is given as no. Whether there is a gauge requirement, it is given as yes. Mounting, it is given as I think this is something wrong is given here. Signal inlet outlet, it is not required here because we have already provided. Solenoid, whether there is an solenoid requirement or not. So in some cases control valve comes with a solenoid, so it is for that. Whether there is a switches, limit switches for on off indication, whether that is required or not. Then air set, this is about the air filter regulator, what will be the set pressure, what will be the uh, filter size, so it is like written 5 micron, and what is the gauge requirement, whether it is required or not, so it is given. Hydro pressure test, it is written as required, but it is not in cryogenic service, so cryogenic requirement is not given. ANSI or FCI leakage class, so it is given as ANSI 4 or leakage class has been provided. And here the all other details like MRR item number, this can be provided. And below that, when everything has been done, control valve has been procured and everything, in that case control valve manufacturer model level, this can be written, and this data sheet then can go to the smart plot instrumentation or other places. So as you can see, there are multiple notes also given there, note 1, note 2 somewhere. So in the next page, normally the client or the EPC provides their own notes if there is something specific to that particular devices, and that is mentioned in the next page. So this is an overall a brief overview about the control valve datasheet. Hope you have understood how to read the control valve datasheet and what are the different components of it. Thank you.